Welcome to Study Loop.
Let's use partial fraction decomposition to evaluate the definite integral from 0 to 1. Looking at this fraction, we see that there's a quadratic in the denominator. So let's go ahead and try to factor that. So does this denominator factor? Sure does. We can take x minus 2, x minus 3. So this is what the book would call case 1. We have distinct linear factors, non-repeated. So we have a over x minus 2 plus b over x minus 3. So this is the form for the partial fraction decomposition. And now we'll have to use algebra here to solve for a and b. So looking at this equation here circled in red, let's go ahead and multiply both sides by the denominator on the left. So multiplying by x minus 2 times x minus 3. On the left, the denominators will cancel. And on the right-hand side, we have a x minus 3 plus b x minus 2. And let's just go ahead and rewrite the right-hand side. Let's pull out the x term with x, and then we have a plus b. And then we have minus 3a minus 2b. So on the left-hand side, we see that the coefficient in front of the x is a 1. On the right, it's a plus b. So we must have a plus b equals 1. Similarly, the constant term on the left is minus 4. But on the right-hand side, the constant term is minus 3a minus 2b. So this gives us a 2x2 system of equations to solve for a and b. And that last equation there, you can go ahead and multiply by a -1. Many ways to solve these systems. For example, we can take the first equation, solve it for b, and then we could plug this value of b into the other equation, and then solve for a. In doing so, we'll have 3a plus 2, 1 minus a, equals 4. And this will give us a plus 2 equals 4. So a equals 2. And then let's take this value of a, plug it into this equation up here, and we get b equals 1 minus 2, which is minus 1. So we found a and b. So now we're ready to integrate. Let's come to the original problem, the original integral in the top left. We can rewrite this. So we replace the fraction with the partial fraction decomposition over here in the far right, upper right corner. And we've just found a and b. So I have 2 over x minus 2. And then for b, we have a minus 1 over x minus 3. And this new integral should be easier than the original. Now, if this x minus 2 or x minus 3 is bothering you, you can go ahead and do a u substitution. U equals x minus 2, and for the second one, x minus 3. And by doing so, after simplifying, we should have 2 natural log absolute value x minus 2 minus natural log absolute value x minus 3 from 0 to 1. Let me separate this from our scratch work. We've evaluated the integral. We have the natural logs. Now we just plug in the endpoints and simplify. So when we plug in 1 first, we have natural log of -1, but we have absolute value. So that just becomes a 1. we have natural log of 1 minus 3 is negative 2. Take the absolute value. You just put a 2 there. And then when we plug in 0, the first term will become 2 times natural log. We have a negative 2 there. Absolute value makes it positive. And then finally, we'll have a natural log of positive 3 after we take absolute value. And then just go ahead and simplify as much as you can. We know natural log of 1 is 0. Combining these natural log of 2's, we'll have negative 3 ln 2. And then watch out for this double minus here. That becomes a plus ln 3. And there's many ways to simplify this. For example, we can write this as ln 3 minus ln 8 by using one of the log properties that says you can take the coefficient in front of the log, bring it inside, but then you have to raise it to the exponent. So 2 to the 3 is 8. And then I could use another property of logs. Log, if you subtract the logs, you can rewrite it as a fraction, log of a fraction. So it looks like any one of these will be the right answer. Let's just maybe narrow it down to these two right here. And that's our final answer.